Picture this, a bustling construction site where every measure matters. Imagine a vast landscape where boundaries need to be defined with on-point accuracy. This is where Theodolite steps in, bringing a blend of technology and offering unparalleled precision that transforms a simple plot of land into a canvas of data. By the end of this video, we'll help you to understand the basic components, the ins and outs of a Theodolite. To learn crucial safety practices to create a secure environment and to set up your Theodolite with ease. Worry not, we got you covered.
Before we try to set up, let us know the key components of the Theodolite.
Our main ingredient is Theodolite. To ensure balance, the Theodolite relies on a circular and plate bubble levels. It is mounted securely on a tripod with leveling screws, a tri-back clamp, and other adjustable screws. Its telescope has to be aligned with precision towards a survey point. This helps you to record your data just by devising the keys on the control panels. And from its display, retrieve your results, which are the horizontal vertical angles.
Surveying is like an adventure, but safety is our superhero cape. Here's why it is important. Number 1. Gear upright. In surveying, safety gear is our superhero suit, vest, and hard hats. They protect us from unexpected stuff like falling debris. 2. Avoid hurdles. It is also a bit like a game. We steer clear of obstacles like rocks on a path to keep things smooth and accident-free. Number 3. Stay away from busy zones. And then, think of a crowded street or a construction site like a busy beehive. We stay far away from them to avoid interruptions while we are in the middle of our work. Remember, safety gear and smart practices are our surveying shields, keeping us safe while we work.
For setting up the tripod, choose a somewhat flat area. Establish a survey point and adjust the legs longer or shorter to set the height you want. Attach and direct a plumb bob towards the survey point. Secure each foot on the ground firmly. Put the equipment on top of the tripod, then attach and secure it using the screw found at the center of tripod head. For leveling the Theodolite, find the bubble levels on the instrument. But for now, focus on the circular level found on the tree branch of the Theodolite. Adjust the tripod legs until the bubble is in the middle of the circle mark. Once leveled, your tripod and Theodolite have been set up.
For mounting and balancing the Theodolite, firstly, you need to do a stability check. Inspect and secure all adjustable parts to ensure the Theodolite is stable and is well attached. Leveling. When leveling, focus on the plate level. Rotate it parallel to two leveling foot screws. Adjust both screws outward until the plate level is centered. Rotate 90 degrees, level using a third screw. Rotate another 90 degrees, level using the original two screws at the back. And rotate the final 90 degrees, Center the bubble using the third screw. And lastly, balance check. Confirm balance by keeping the bubble centered. Now, your theodolite is balanced and securely mounted.
In turning theodolite on, look for the button that turns the tool on. Press and hold the power button until the display screen lights up. The tool will show some numbers and lines while it gets ready. This is called initialization. Calibrate the keys on the operation panel to make sure they're working just right. The initialization helps to get ready for accurate measuring, to attune the sensors inside the tool to make sure they're working properly, to ensure precision in the internal system to give us correct measurements. Now, your theodolite is ready.
Remember, the theodolite only measures two parameters, horizontal angle and vertical angle. First, the vertical angle here is measured as zenith angle, wherein 0 degrees is straight up, 90 degrees is horizontal, 180 degrees is straight down, and 270 degrees is the opposite direction. Second, horizontal angle will be indicated on the bottom of the display panel. When you click the offset key twice, the angle will be set to 0. From the horizontal scale, it will be up to you if you rotate left or right. Just click L/R key to set up the direction of the theodolite. Remember also to assess the units to use for your surveying. Consistency of units and coordinate system is key to precise measurements. That is all.
To aim and focus the theodolite, number 1, look through the telescope. Second, look for the thin lines that form cross in the center. Those are crosshairs. That's where you aim. The crosses usually have 3 sets on them. They're mainly called the upper, center, and the lower stadia hairs. Third, find the focus ring around the telescope and turn the ring until the view becomes clear and sharp. Fourth, establish a survey point. We typically utilize a rod with the incremented measures in centimeters, which is a standard measuring tool being used for surveys. With this, you can now aim and record for precise measurements.
To apply our learnings, we will try to measure a closed traverse with 5 stations. Here's the concise step-by-step process. First, establish the control point. Place a wooden hub for the first station. This is where we choose a stable and level location for the theodolite setup. Second, find the south direction degree reference using a compass. This is where we are going to face the theodolite. The horizontal angle shall be set to 0. Then, set the theodolite into a vertical angle of either 90 or 270 degrees. For civil engineers, in terms of azimuth, we refer to the south direction as our base reference for measuring the horizontal angle. Third, place any instrument markers like chaining pins or anything that works to establish the stations of the closed traverse. Fourth, measure distances between consecutive points using a tape measure. Fifth, start measuring for the traverse in terms of azimuths. From the first station, rotate the theodolite directly towards the second station. Aim the crosshairs towards a survey point, in which in this demonstration, a rod was being used. Then, record the horizontal angle data as shown. 6. Move the theodolite to the second station of the traverse. Repeat the process of sighting, recording angles, and measuring distances on the rest of the stations until we can complete the measurements of the closed traverse. Be consistent on the direction as to where we shall rotate the theodolite in terms of horizontal scale. In this case, our rotation was consistent towards the right direction. 7th, plot as a plan or map the closed traverse points using the measured azimuths and distances. If you have knowledge in the AutoCAD software, then you can plot the data using simple keys and command functions. We used AutoCAD to see if the traverse is really a close boundary. After plotting, we observed a tiny opening between the 5th and 1st station, but that's okay. Surveys are always subject to errors, especially if we deal with angles. 8th is to employ corrections. In applying the corrections, we went through this process. First, convert the azimuths to bearings of the traverse. Second, compute for the latitudes and departures of each station using the corresponding formulas. Third, compute for their errors by summing them up and giving high regards to the sign convention. Then also compute for the error where the negative signs are disregarded. Fourth, balance using the method of transit rule. These are the formulas both for latitude and departure. Computing for this gives the values for the correction. Fifth, apply these corrections to the original values and get the final adjustments of latitude and departure, wherein if you sum them all up, both of them shall be equal to 0. Lastly, to get the corrected bearings and distances, we used the Pythagorean and inverse tangent formulas. 9th, we plotted a final map for our closed traverse, wherein this time, we used the data that was already corrected.
To summarize the key steps, remember to securely position and adjust the tripod for stability. Mount the theodolite tightly into the tripod, ensuring a firm attachment. Switch on the power button of theodolite. Configure control panels for accuracy, and align it to record surveying measurements. The more you practice with these steps, the easier it gets. Remember, every surveyor started by mastering the basics. With the architects laying precise building foundations, or archaeologists mapping ancient ruins, theodolites make these real-life feats possible. Keep exploring and expanding your surveying skills. Thank you for watching.